Mrs. Blocks, science. Da 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 da.
Today's topic is equilibrium from the rates and equilibrium unit. So the definition of an equilibrium is a reversible reaction, happens in a closed system, and the rate of the forwards reaction is equal to the rate of the backwards reaction. Okay, so the rate of the forwards reaction is equal to the rate of the backwards reaction. This is very important because it leads to something called Le Chatelier's principle. Le Chatelier's principle is fairly straightforward. An equilibrium will counteract, in other words, undo, oppose, change, the effect of any changes made on it. So, for example, if we increase the temperature, the reaction will react and respond in a way that is likely to reduce the temperature. If we increase the concentration, it will try to reduce the concentration. So that is Le Chatelier's principle. It will counteract the effect of any change made to it. Okay, so how are we likely to meet this in an exam? We are likely to meet it in the form of position of equilibrium. Left to themselves, with the same conditions, temperature, pressure, concentration, reactions that are reversible will establish an equilibrium where the proportion of each reactant and product is constant. And that is what is referred to as equilibrium. However, if we make a change to the equilibrium, it will counteract the effect, and therefore it will shift from where its starting point is to a different balance. And that is referred to as the position of equilibrium. And we refer to that as moves to the right if it is making more products, or moves to the left if it's making more reactants. And which way it will go will be dependent on the change that is made to it. So you're most likely to meet this in an exam question as the effect on the position of equilibrium. And that will depend on the data they give you. So if the change is increase concentration of reactant, that means the equilibrium is going to try and reduce that concentration, and the way in which that happens is to move the position to the right. By making more products, we are reducing the concentration of the reactant and trying to undo the effect of the change. Okay. So just put the effect of composition. or decrease the concentration of product, for example, by removing the product as it's produced, then again, both of these factors move the position to the right. Okay. If we increase pressure, so now if it's a gas, we could increase pressure. And this is tricky because increasing the pressure only affects gas moles. So your reaction has got gas in the equation, we increase the pressure, the number of gas moles is going to control what happens. So it depends on the gas moles. So that means we have a little bit in the middle between the effect. So if there's more moles of gas on the left, if you increase the pressure, then you move position to the right. Because the equilibrium will try to undo the effect of that extra pressure by making fewer moles of gas. If we have more moles of gas on the product side, on the right of the chemical equation, then we move the position to the left. And as a result, the effect on the position of equilibrium will depend on your chemical equation. And remember, if it is a gas, you will see it by the state symbol being G, and you simply count the number of moles by counting the numbers in front of the formulae. If there's no number in front of the formula, then that means there's 1 mole of that gas. The other tricky one for changing the position of equilibrium is temperature. So I'm going to talk about an increase in temperature, but they might choose to talk about decrease in temperature, and all that happens then is it's reversed. And that depends on which direction is exothermic. We have to remember that whichever direction of the equation is exothermic, the opposite, so the reverse of that reaction, is then endothermic. So, if forwards is exothermic, that means making products will release heat energy. Making products will release heat energy. It's an exothermic reaction. Therefore, by Le Chatelier's principle, the equilibrium is going to try and reduce that effect by trying to reduce temperature. And the way in which temperature is reduced is with the endothermic. So therefore, if the forwards reaction is exothermic, the reverse is endothermic. And what will happen is that the position of equilibrium will move to the left to favour the endothermic reaction. If then the backwards is exothermic, so the backwards reaction is exothermic, now making reactants gives you more heat energy. That means making products gives you less heat energy. So the position moves to the right. And with all of these, it will depend on the data in the question because that's how you can tell which way is exothermic, which way is endothermic, and what's going on. Having understood how equilibrium work, now we're going to look at an exam practice question. So in this exam question, the context is ethanol produced from steam and ethene, and it's given the chemical equation in the data. So this is important. And as you can see from the chemical equation, we've got gas, so therefore pressure could be a factor. It shows you a flow diagram to show how the reactor is then used, and it shows that you've got your reactants, ethene and steam, going into the reactor, and then any unreacted reactant comes out with the mixture of ethanol and water being separated. So why does the mixture of the separator contain ethanol and water? It's because ethanol is soluble and both of these chemicals will condense. So basically ethanol and water both condense in the separator. To form liquids. Okay. Now, here we come on to the first bit where we have to use our understanding of equilibria. The Forwards reaction is exothermic. So that tells you that going from reactants to products is exothermic. So that means this reaction is going to generate heat energy. So any increase in temperature is going to try to remove it. So the effect of increasing the temperature is it's going to try and reduce temperature, therefore go in the endothermic direction. So now we've understood that, we need to think, well, which way is that? Look at the equation. So up here, reactants to products is exothermic, therefore products to reactants is endothermic. And now we can say what will happen to the position of equilibrium and the effect on the amount. So therefore, the position of equilibrium moves to the left. Therefore, reducing the amount of ethanol. And the second question here, explain how increasing the pressure of the reactant. So pressure, remember, is just those with gas. We need to look at the chemical equation. We've got 1 mole of gas here, 1 mole of gas here, makes 1 mole of product gas. So there's 2 moles on the left, 1 mole of gas on the right. So explain how the pressure, so the equilibrium reactants, 2 moles, products, 1 mole, therefore increasing pressure goes to the side with fewer moles. So that moves to the right. And as a result, more ethanol will be formed.